This is assembly of quarter joint. Quarter joint. What's the main use of quarter joint? Quarter joint is used to connect two rods subjected to axial tensile or compressive loads. It is not suitable to connect rotating shafts which transmit torque. Axes of the rods to be joined should be collinear. Right? There is no relative angular moment between rods. Quarter joint is widely used to connect the piston rod and crosscut of a steam engine as a joint between the piston rod and the tail or pump rod, foundation, etc. Foundation bolt, etc. The quarter is usually made of mild steel or rough iron. Advantages of quarter joint: simple to design and manufacture, simple to assemble and dismantle, very high tightening force due to wedge action which prevents loosening of parts in service. Types of quarter joint: we can classify it into three types. First one is socket and spigot quarter joint, then sleeve and quarter joint, final one is gib and quarter joint. At first we are going to discuss socket and spigot quarter joint. Okay, this is socket and spigot quarter joint. Okay, here in this quarter joint, both sides the tensile load is acting, right? The load considered as P, small d is diameter of the shaft, right? And in center, the socket and socket collar is assembled with the quarter. Okay, remaining all are its parameters given as shown in figure, right? Small d1, d2, b, d, d4, t1. Okay, design of socket and spigot quarter joint. Let P equal to load carried by the rods, small d equal to diameter of the rods, d1 outside diameter of the socket, d2 diameter of spigot or inside diameter of socket, d3 outside diameter of spigot collar, t1 equal to thickness of spigot collar, d4 diameter of socket collar, c thickness of socket collar, b mean width of quarter, small t thickness of quarter, L equal to length of quarter, A equal to distance from the end of the slot to the end of rod, right? Sigma T permissible tensile stress for the rod's material, tau equal to permissible shear stress for the quarter material, sigma C permissible crushing stress for the quarter material. Okay, next we are going to the design procedure for quarter joint. Okay, first we want to find the failure of the rods in tension. That is suitable formula P equal to pi by 4 d square into tau t. Okay, this is the formula to find the failure of the rod in tension. From this equation, diameter of the rod may be determined, right? Failure of spigot in tension across the weakest section or slot. Okay, that diameter we can consider as d2, right? Thickness small t, that is suitable formula P equal to pi by 4 d2 square minus d2 into t into sigma t. From this equation, the diameter of spigot or inside diameter of socket d2 may be determined, right? In actual practice, the thickness of quarter is usually taken as d2 by 4. Then failure of the rod or quarter in crushing. P equal to d square into T into sigma C. From this equation, the induced crushing stress may be checked. Okay. Fourth one, failure of the socket in tension. Right. Inside diameter D2, outer diameter D1. Right. That suitable formula P equal to pi by 4 D1 square minus D2 square and minus D1 D2 into T within bracket sigma T. From this equation, outside diameter of socket D1 may be determined. Then failure of cutter in shear, right? That structure also structure is shown in figure. P minus 2B into T into tau. That is the suitable formula, right? From this equation, width of cutter is determined, small b we can find, right? And failure of the socket collar in crushing, P equal to D4 minus D2 into T into sigma C. From this equation, the diameter of socket collar D4 may be obtained. Okay. From previously, you can find failure of cutter and shear, right? Here P equal to 2V into T into tau. This is the suitable formula. Here P equal to within bracket D4 minus D2 into T into sigma C. Here also we can find D power D4, right? Failure of socket end in shearing, right? P equal to 2 into D4 minus D2 into C into tau. Here from this equation we can find the thickness of the socket collar C may be obtained, right? Then failure of rod end in shear, P equal to 2A into D2 into tau. From this equation we can find the distance from the end of the slot to the end of the rod, A, small a may be obtained. Then failure of spigot collar in crushing, right? That figure also shown in figure, shown here, D2, small d, inner diameter D2 and D3 outer diameter, right? That is suitable formula P equal to pi by 4 within bracket D3 square minus D2 square into sigma C, right? Here from this equation we can find the diameter of the spigot collar D3 may be D3, right? So failure of the spigot collar in shearing. Failure of the spigot collar in shearing. Okay. That the suitable formula P equal to pi D2 into T1 into tau. Final one, failure of cutter in bending. The maximum bending moment occurs at the center of the cutter. So it is given by the maximum M max equal to, okay, M max equal to P by 2 within bracket 1 by 3 into D4 minus D2 divided by 2 plus D2 divided by 2 minus P by 2 into D2 by 4. Okay. So M max, maximum bending moment, M max P by 2 into D4 minus D2 divided by 6 plus D2 by 2 minus D2 by 4, that is equal to P by 2 within bracket D4 minus D2 divided by 6 plus d2 by 4. We know the section modulus of Carter Z equal to T into B square by 6, right? If we substituting this value in this equation means sigma B bending stress induced in the Carter, sigma B equal to M max divided by Z. Okay, so section modulus we know T into B square divided by 6, right? If we substituting here means we can get P into P within bracket d4 plus 0.5 d2 divided by 2T into B square. Okay, this is bending stress induced in the Carter should be less than the allowable bending stress for the Carter. Then length of the Carter L is taken as 4D, right? After that, the taper in Carter should not exceed 1 in 24. In case of the greater taper is required 1 in 24. In case of the greater taper is required, locking device must be provided. The draw of Carter is generally taken as 2 to 3 mm. Right? This is the design procedure to solve Carter chart. Okay. Thank you.